where you are. Now that you can see sound, a world of possibilities opened. You're no longer groping in the dark, as they say, which means you can actually look at note patterns as they appear on the guitar. So in this lesson, that's exactly what we'll do. And in the process, you'll learn the terms that musicians use to describe these patterns, basic labels for the notes and intervals that are fundamental to music theory. What you will learn in this lesson. Here's a quick preview of what we'll cover in lesson 2. You'll look in more detail at the holy trinity of music patterns, the chromatic scale, the major scale, and the circle of fifths. Using these 3 patterns, you will learn how to navigate the guitar fretboard in all 12 keys. Using colors and shapes, you'll learn how to label all the intervals using numbers called scale degrees. Finally, you'll see how colors streamline your understanding of notes and intervals using one simple set of symbols. The fractal nature of sound. In lesson 1, you learned that music isn't as complicated as it seems, right? Now that you can literally see sound, that is, which is the very definition of music theory. So you can literally look at music to understand its design and the way it truly functions. And in this process of visualizing sound, you found that all music is built upon 3 patterns, which include the chromatic scale, the major scale, and the circle of fifths. Just 3 simple patterns that lead like doors towards sonic bliss, where each one brings you closer to a better glimpse of music itself. In a word, it's wonderful, because the simplicity of it all means that you can easily master the science of music to then perfect the art of songwriting too, as you will see ahead. But as you found in lesson 1, these patterns also have a surprising twist, and that each one is just a variation of the others, so that all 3 are simply permutations of the same 12 notes. To illustrate, this image shows you what I mean. In essence, the chromatic scale is what forms the major scale, which then forms the circle of fifths, which in turn is what forms the chromatic scale once again. It's a seamless and cyclical metamorphosis, right? And in reverse, the same is true as well, where moving from right to left, the chromatic scale turns into the circle of fifths, which then morphs into the major scale, which then leads back into the chromatic scale once more. In other words, each pattern is simply a rearrangement of the next, which is why the major scale sounds so good. Because the major scale, like the chromatic scale itself, is really just a circle of fifths sequence that has been transformed, you see? Or better said, you might think of the major scale as a hybrid of both the chromatic scale and the circle of fifths, since it displays elements of each, like a mutual homage through which one pattern pays tribute to the other, and vice versa, you could say, where the major scale stands as a kind of self-reference to each pattern's own reincarnation. In short, it's beautiful, elegant, and badass. Like a fractal universe that folds back onto itself, these 3 patterns form one unified whole, or what you might call the holy trinity of music. And now that you know how they're connected, you can proceed with ease. The guitar fretboard. Of course, all this talk about fractals and reincarnation might seem a bit off topic, since all you really want is to play the guitar and compose songs right, not delve into abstract philosophy. Yet it's all totally relevant to the guitar because the fretboard happens to be the perfect embodiment of all 3 patterns. So once you understand the connection between them, you have a serious advantage. To see what I mean, check out this image, which shows how the guitar is basically a mix of 2 essential patterns, the chromatic scale and the circle of fifths. We'll get to the major scale in a moment. You can see how these patterns intersect, right? In fact, you really can't miss it with the colors just sitting there staring you in the face. Each string follows a chromatic scale pattern from left to right, as you saw in lesson 1, while every fret forms a circle of fifths sequence from top to bottom. And the result is a tapestry or matrix that combines both patterns into one. So the fretboard forms a kind of super pattern that looks like this. It's awesome. And with this interlaced framework, you now have everything you need to make music. Or at least that's almost everything you need, since the chromatic scale and the circle of fifths don't sound especially musical on their own, and instead simply represent how sounds are organized in music, as you also saw in lesson 1. So to make this matrix sing, as it were, we have to use the 3rd pattern of the Holy Trinity, the major scale, which serves as the natural link between the other 2 patterns and helps you keep your bearings as you play. For example, take a look at this C major scale to get a feel for what I mean. In this image, all the sharp and flat notes are faded so you can focus on the natural notes of the C major scale alone. And as a result, it's easier to navigate the fretboard as you move from one note to the next, right? But because there are still so many notes filling the fretboard, it can still seem a bit overwhelming at first glance. So to make this matrix more manageable, we can trim it down even further, like this, by looking at only one string at a time. And when you do this, it suddenly becomes clear that each string is simply its own major scale, derived from the chromatic scale, where the notes are laid out from left to right. You see? In fact, try playing this pattern as you slide your hand up the string, pressing the notes like a series of stepping stones, and you'll hear that it sounds really good. It's cool, right? And what's even better is that all the strings follow the same basic pattern, which you can see when all the major scales are displayed once more, like this. In essence, this same pattern is repeated on every string, with the only difference between them being where the notes happen to fall, based on how the strings are aligned with one another. It's simple, really. You see, the guitar wasn't designed with all the strings arranged in neat little rows where the same notes are stacked in columns, like this. Instead, the notes on the fretboard form a more interesting pattern, a staggered and consistent array that's influenced by the circle of fifths. To explain, imagine the notes on each string are like colored beads, and that we can slide the strings in relation to one another, left or right, so these beads can align vertically in different ways. And of all the patterns that are possible, the most interesting one appears when the beads/notes form a stack of fifths near the center of the scales, so the colors align from top to bottom, like this. Can you see it? This alignment explains why the notes are arranged as they are on the fretboard, because the whole pattern is the product of both the chromatic scale and the circle of fifths, as you know, where the notes form a matrix that can be traversed via the major scale. So when you fill in the rest of the notes and remove those that don't really exist up by the tuning pegs, you get the standard array of pitches as they appear on the guitar. Or at least you get this arrangement once you add a slight shift to the top two strings, as you do with the standard tuning, like this. Later on, we'll learn why this shift became common, which was basically to simplify the fingering for various chords. But for now, the point here is that this pattern is plain to see, right before your eyes, with the help of color music. And next, we'll explore this matrix even more so you can really begin to master it and use your newfound knowledge to actually make some music. Navigating the matrix. Without question, the guitar fretboard is amazing. Not only in the way it blends the patterns of music into a compact grid, but also because it's just so beautiful. I mean, when you look at this matrix, it's mesmerizing, right? Like an abstract painting you could hang on your wall as art. Yet this pattern has much more use than just that, of course, because it also reveals the essential science of music. A science that's totally predictable, as it turns out, and practical too, in the way it helps to guide you as you go. For example, try playing the C major scale again, and this time, notice how your fingers can move more easily now that you know how the notes are arranged. In fact, once you know your way around, you can even branch out a bit to play this pattern in new and interesting ways, and in more efficient ways, like this. By dividing the scale into segments this way, and by moving from one string to another, you can play this pattern more swiftly since your hand maintains a tighter range of motion as you go. Get it? You'll see what I mean when you try. So really, press each note with your fingers, and notice how you can cover a wide range of pitches in such a small space. It's awesome. And what's even better is that once you understand the layout and logic of the guitar, you can go further still by repeating this same scale on even more strings, like this. There's nothing to it really, because all you have to do is move your hand a little, and every note is the same as before, laid out in the same sequence with all the same intervals, albeit with a slight shift in the top two strings, as you saw earlier. And just like that, you can start to navigate the fretboard with ease, fret by fret and string by string, moving with total confidence since the colors remove any need for guesswork. Though as you'll see next, this is only the beginning, because there's even more of this pattern to explore. All major scales. To be sure, the major scale is marvelous because it plots your path across the fretboard, like a series of stepping stones that show you the way so you can move in all directions. And as you've seen so far, the C major scale has been the example used to illustrate this pattern, which serves as a natural link between the chromatic scale and the circle of fifths. It's a nice, simple sequence of notes you can play up and down the strings in even more positions than you've already played, as it turns out. But of course, the C major scale isn't your only option because all keys work in this same way. So you can play this same pattern, the major scale, anywhere you'd like on the fretboard, starting on any note to play any scale in any key. For example, play the G major scale beginning at the bottom string, and you'll see that it forms the same predictable pattern of whole step and half step intervals that you already know by now. It sounds familiar, right? Because really there's no difference between this G major scale and the C major scale you played before. For while the specific notes are unique, the underlying intervals are the same, making both scales virtually identical. And as you learned in lesson 1, this is true for all major scales, where each pattern simply starts on a different note. So the D major scale begins on D, for example, while the A major scale starts on A, the E major scale starts on E, and so on. To hear and see this for yourself, play through the following scales, which include a low-pitched and high-pitched version of this pattern in every key. And notice how they all follow the same consistent pattern of intervals, no matter where you are on the fretboard. The key of C. The key of G. The key of D. The key of A. The key of E. The key of B. The key of G flat. The key of D flat. The key of A flat. The key of E flat. The key of B flat. The key of F. So what do you think? Each scale is easy to play, right? Not only because you can literally see the notes, which helps of course, but also because each pattern is essentially the same. Up and down the fretboard, all of the scales are basically identical because they're all formed from the same set of intervals. So once you've learned one scale, you know them all. Get it? And this point is important as we move forward. In fact, it's so essential to your mastery of music that we'll look more closely at these intervals throughout the rest of this lesson. And as you will find, like everything else in music, intervals are super simple once you really know how they work. But before we move on, take the first quiz of lesson 2 and go through the first set of exercises. That way you'll know how well you understand the key concepts, and you can apply what you've learned to ensure you really get it. Again, feel free to print the PDF so you can write your answers directly on each page. And once you've aced it all, let's keep moving forward by looking at musical intervals in even more detail. The importance of intervals. So far, you've already learned a lot in this course, from the 12 basic notes of music, to the layout of the fretboard, to the way you can actually make music on your guitar. And along the way, it's all been fairly simple because these otherwise invisible, abstract concepts are now concrete with the aid of color. So you don't have to picture everything within your mind's eye only, but you can actually see it all right there in vivid detail with your own two eyes, unhurried and at your own pace. And with this new vision, one thing has become clear, that music is all patterns. Patterns, patterns, patterns. Regular, repeating patterns that are totally predictable, natural patterns that are simple and symmetrical, which have always been audible, but are now plain to see as well. And of course, the three most important patterns by far are the chromatic scale, the major scale, and the circle of fifths, that together form the foundation of music. And it's an elegant framework where each of these patterns is just a variation of the others, produced by its own set of intervals, where the intervals used are what really set each one apart. To see what I mean, check out this image, which shows all three patterns together as concentric rings that stem from the same source. At the center is the chromatic scale, the most basic sequence of notes where every pitch is separated by a half step, you see? Then in the next ring, the major scale is formed as a subset of notes created by a pattern of whole steps and half steps, so that some of the notes from the chromatic scale are skipped. And finally, around the edge is the circle of fifths, where every fifth note of the major scale is shown, as the name circle of fifths suggests. In this way, every pattern is derived from the one before it, all through the use of intervals. Get it? So now, it only makes sense for us to look more closely at these intervals since they hold the key to a deeper understanding of music. And specifically, we'll analyze the intervals that make up the major scale, because this pattern is what brings everything together. And as you'll see next, it's also important because it explains how musicians label every interval using a set of symbols we call scale degrees. Scale degrees. Without a doubt, scale degrees are important in music because they inform everything you'll learn going forward. But that's not to say they're complicated by any means. In fact, they're actually quite simple. To explain, let's start with the C major scale as an example. Though in the next few minutes, you'll see how these same principles apply to every key since all 12 keys are symmetrical. As you know by now, this scale is formed from a basic pattern of whole step and half step intervals, where you start on one C note in the chromatic scale and then work your way to another, playing only some of the notes in between, like this. Whole steps are shown by the letter W, and half steps are shown by the letter H. Easy enough, right? And to label these notes, we give each one its own letter name. C, D, E, F, G, A, B, C. But because the intervals are also important in this pattern, it turns out they have labels too, which musicians mark with a set of numbers they call scale degrees. So called because they measure each degree or interval in the major scale. Get it? So when you play this C major scale, you can think of it in a couple of ways. As a specific sequence of notes, C, D, E, F, G, A, B, C, or as a general pattern of intervals, 1, 2, 3, 4, 5, 6, 7, 8, which happens to start on C. Both patterns produce the same results, of course, but you get there in different ways. While the letters spell out the exact pitches to play, the scale degrees plot a more general path through space by highlighting the distance between the notes, rather than the notes themselves, you see? And as a result, these scale degrees are a more universal tool for analyzing any key, a tool that you can use like a musical ruler, if you will, shifting it from one key to the next, measuring the distance between notes, and marking the pitches to play, whether you're in the key of C, or the key of G, or D, etc. It's pretty cool, right? Though clearly it's not the kind of ruler you see in the real world, meant to measure physical objects like a pencil or rock. Instead, it's a different kind of ruler indeed. A musical ruler marked by only a few unevenly spaced numbers that give it a funky look. But for as strange as it seems, this weird design is totally natural because it's caused by the intervals that form the major scale itself. Which is why it's unlike a normal number line, so the integers aren't evenly distributed, but instead are offset by large and small gaps. Get it? Or at least the main scale degrees are spaced this way, those that mark the major scale anyway. Though really, every interval of the chromatic scale has its own label, including the ones that are skipped in the major scale pattern. And these scale degrees are simply written as numbers with extra sharp and flat symbols, just as you saw in lesson 1 with the letter names. The same basic idea applies. The scale degree just below 2 is flat 2, and just below 3 is flat 3, and just below 5 is flat 5, sometimes called sharp 4, and so on. I should point out that as a convention, the sharp and flat symbols are written after a given letter name, but before a given scale degree. For example, D flat versus flat 2. It's just what musicians do. Anyway, back to the scale degrees. To be sure, it's an odd-looking sequence, but one that makes sense once you understand its logic, and the fact that these numbers essentially favor the major scale, although every interval is labeled to fill in the gaps. And as a result, this musical ruler forms a full and complete set, which we can now use to map out the intervals on the guitar for an even better understanding of the fretboard. An understanding, that is, that will help you navigate the matrix even faster, moving quickly between the notes in any key with total confidence. Scale degrees on the guitar. To see what I mean, let's apply these numbers to the fretboard, starting with the key of C, and you'll find that it's super easy. All you have to do is align the number 1 with every C note, and the other scale degrees fall into place, forming an array of musical rulers, if you will, that are staggered on the different strings. Cool, right? So you can play this pattern anywhere you'd like, as one long sequence on a single string, or in segments across multiple strings, or even repeated in different positions just as you did before when looking at the letter names for the notes. Only now the scale degrees illuminate these patterns even more clearly because they highlight the intervals used to play each scale. That is, they emphasize the whole steps and half steps that make up the major scale, inherently showing the distance between notes, which informs how far your fingers must move across the fretboard. So now it's even more obvious why the guitar is such a brilliant design, and why you can play patterns so quickly on the strings. Because the fretboard allows you to cut through space with almost impossible speed by putting otherwise distant intervals in close proximity, so you can leap between them in only a fraction of the time. For example, on any given string, intervals 1 and 3 are separated by 2 whole steps. But on 2 strings that are stacked, the physical distance between them is relatively small. You see? And as a result, you can move between these points more swiftly, jumping from one to the other in a flash, as if swept through a kind of wormhole. In fact, when you think about it, it's pretty far out. And of course, because all 12 keys are symmetrical, it gets even better because you can apply this pattern to all 12 keys. You just have to shift the scale degrees so the number 1 aligns with a different note, and bam, you're in a new key, whether it's F or C or D, etc. Get it? To see for yourself, check out the following major scales and play each one again. Only this time, count the scale degrees as you go, paying attention to how you can pass through such a wide range of pitches in such a small space on the fretboard, all by moving between strings to play the scales in segments. The key of C. The key of G. The key of D. The key of A. The key of E. The key of B. The key of G flat. The key of D flat. The key of A flat. The key of E flat. The key of B flat. The key of F. Two birds, one stone. As you played through the last few scales, did you notice anything different about the diagrams? That is, any difference between the major scales marked by numbers and those labeled by letters? Obviously, the symbols used are different. So the scales you played earlier in this video show the letter names of the notes, while the patterns you just played highlight the scale degrees or intervals used instead. That much is clear. But what I mean by difference is something more subtle. And actually, it's a distinction so fundamental to music that it's important to point out here, which is this in a nutshell. While the letter names of the notes are fixed, meaning they stay the same from one key to the next, the scale degree numbers are variable, meaning they shift or change to align with each new key. And as a result, these two sets of symbols, letters and numbers, function in very different ways. In fact, to picture these different functions, imagine that both the letters and numbers are printed on transparencies, where all the letter names are on one sheet and the numbers are on another, like this. In essence, the layer of letters always stays in place, fixed to the fretboard in one spot. But the layer of numbers, the scale degrees, can slide around in any direction to highlight the intervals in all 12 keys. You see? As an example, play through these 4 major scales and notice how the letter names are the same from one key to the next. So no matter what key you're in, C is always C, while D is always D, and E is always E, etc. But then, when you use the scale degrees instead, you can see how the numbers move around the fretboard, fixed in relation to each other, but variable in how they align with the different keys, so that 1 marks C in one key, then G in another, then D in another, and so on. It's pretty cool, right? Because with both kinds of symbols, letters and numbers, we can identify the specific notes and the intervals between them, all through the use of a few markings. Symbols that together make up the vocabulary of music, the terms we use to describe each pitch and scale degree to communicate with each other about the way music works. Which is awesome, of course, because now we have a way to actually talk about music theory. But for as useful as they are in speech, these alphanumeric characters have their drawbacks too, with the most glaring one being that they're not nearly as good on the eyes. In fact, this dual system of symbols can become so visually complex that it's a problem because it can trip you up by adding more confusion than clarity. For example, when you combine both the letters and numbers into one image, the result is a mess, a jumbled cacophony of incongruent characters that mystify instead of simplify, right? And even worse, when you look at all the alphanumeric pairs that are possible in every key, the picture is reduced to sheer nonsense. Do you see what I'm saying? And with all of these dyslexia-inducing symbols used in conjunction, you can easily get lost in the clutter. Though, of course, that was never the intent when these labels were first developed a few centuries ago, back when musicians had to come up with a way to describe the fixed and variable properties of music. But since these symbols were the only real option at the time, musicians didn't have a choice. So with their inkwells filled and their quills in hand, they simply stole a few symbols from other disciplines, taking some letters from linguistics and a few numbers from math to create a hybrid of their own. A blend of markings that were meant to form a clear framework, but instead turned into a tangled web of abstraction where the underlying logic and patterns of music were ironically obscured from sight. But now, with color music, we can cut through this clutter with a kind of X-ray vision to look directly at the patterns that form the foundation of music, all without getting lost in the letters, numbers, sharps, flats, and other man-made symbols. In fact, using color, we can now kill 2 birds with 1 stone, because 1, the colors immediately identify every pitch, the fixed elements of music, more intuitively than the letter names themselves, as it turns out, so you can distinguish each note at a glance. And 2, the colors also highlight the intervals between the notes, the variable elements of music, consistently in all 12 keys, since the colors, unlike numbers, are inherently cyclical and symmetrical, so they outperform the scale degrees as well. So now you can absorb every pattern with ease because this information is baked into the colors already. Which means that when we apply these colors to the fretboard, you can follow the patterns that appear in the resulting matrix, all without the need to count frets, or memorize finger positions, or rely on letters and numbers to guide your way. As we advance in this course, the full extent of this advantage will become clear, and you'll learn to leverage this streamlined interface to truly master theory and the art of songwriting. But to get you up and running and to really explain the patterns you'll see in vivid color, we'll still label the notes and intervals with these symbols. For a while anyway, since letters and numbers help with written and verbal communication after all. But like training wheels that can only go so fast or so far, they have their limits. So eventually you'll be able to move on without them once you learn to see everything for yourself. It's awesome. And as you'll see in lesson 3, it gets even better actually because the colors do more than just pack a 1-2 punch. It turns out they also offer a third advantage beyond simply identifying the notes and the intervals between them. And this advantage is definitely the most powerful one of all. So after you complete the last quiz of this lesson, and the exercises too, read on and you'll see exactly what I mean.